Hello everybody, welcome to the stream. 1 second, I'm just adding a little thing to the description here. Okay, there we are. Alrighty, welcome everyone to the stream. Welcome all you lovelies. I'm so glad to have you all here, and yeah, we'll just hop right into some coding. Let's do it. Okay. And as you can see, I have the chat up on the window here. So everything is looking good. Alright, so I did stream for a little while yesterday, and during that time, I got a few of the Project Euler challenges done already. I got this challenge number 1 done, which is to find the sum of all the multiples of 3 and 5 below 1000. And this was pretty simple to do. All I had to do with the code was basically write a function that checks whether a number is divisible by another number. Then I had to make a list that had all the numbers below 1000 and greater than 0. And then I simply just filtered that list for multiples of 3, multiples of 5, added the two lists together, one like basically end to end. And then after that, I made sure that I didn't have any duplicates, and then I took the sum of that. And I'll just run it here real quick, just so you can see what that sum was. It turned out to be 233,168. So yeah, this is what F# looks like. It's a very pretty language, and I'm excited to share some geeky experiences with you all. So welcome to the stream, and yeah, let's have a good time. Alright. So I'm gonna pop open Project Euler just to get our next challenge. Hi Ouija, welcome to the stream. Yes, it's not super complex, but I hope to give someone or everyone that watches this stream something to learn, whether it be complex or not, or very simple. As long as you walk away from this stream knowing one more thing, I'm happy. Alright, so let's go to the archives. Largest palindrome product, this one is called. So I am going to create a new file here. And add our challenge to it. So this is challenge number 4. And below it, I will add the challenge. Okay. And then here we have our F# code. So let's go ahead and give this a read. A palindromic number reads the same both ways. The largest palindrome made from the product of 2-digit numbers is 9009, which is 91 times 99. Okay. Find the largest palindrome made from the product of 2 3-digit numbers. Interesting. So I'm just trying to get a handle on the problem right now. So numbers that are palindromes are like, 1001, 1111, because they're the same both backwards and forwards. So it's the same as saying race car is a palindrome word, except we're doing it with numbers and digits. So another one would be 3993, and okay. I think we're back. Yes, I believe we are. Okay. Alrighty. So okay, so I've stopped the recording. Hopefully that fixes the issue in the long term. Yeah, the streaming app is in a foul mood today, but I think I have it cooperating now. But we'll see. Okay, so back to our little challenge here. Let's go ahead and just start writing some code. So the best way I think to solve this problem, or the most naive way, would be to check all of the possible products. But I feel like there's a better way to go about it. Because what we could, okay, I think we're back. Looks like we have the connection back. We'll see how long that lasts though. I'm not super confident in that. But yeah, we're back for now. So I think I'm just gonna sit here and wait a minute actually, just to see how well it behaves, and if we have good luck, then we'll keep going. So I am just going ahead and switching to a different scene. Alright, so as you can see, Optimus Prime is over there in the background. But yeah, we're just going to be chilling for a little bit until we know for sure that OBS is gonna be working well. Alright. So I'm just gonna check out the bitrate here. That's looking good. Okay. Excuse me. Everything is looking good. Okay. So let's switch back to our code here. Alright. And I think I'm gonna set OBS to high priority as far as CPU things go, because I do not want it to crash again. Let's go to details. Okay, set priority. Okay, so the priority is already high. Okay, so that's looking good too. Okay. So let's get back to what I was trying to do. So basically, this is the number of possibilities we have to evaluate if we do a brute force approach to this problem. So let's go ahead and make an algorithm that will check all of these palindromes for us. So let is palindrome equal, and we'll take in a number n. Let that be a 64-bit integer. And let's see here. Yes, I should pop up the chat as well. Okay, I will go do that. Pop out chat. And paste the link into here. Okay. There we go. There's the chat. Alright. So let is palindrome equal, and then we'll simply spooky scary skellies. Yes. And by the way, how's the audio, Ouija? Is it sounding good? And I believe there is a string that reverse. Okay, it sounds good. Perfect. Actually, I believe we can do sequence dot reverse. Then convert that back to a string. So basically what I'm gonna do here is take in a number, convert it to its text form, then reverse it, and check if it's equivalent to its string form. Or so its text form. So let's do forward equals this, and then let backward equal forward, and then pass that to reverse. And what we want to do is turn this back into a string. I'm not sure how exactly to do that. I think I should just be able to do that. And it should figure out the conversion on its own. Or perhaps, let's see. Yeah, I think we'll do it this way. Okay. Yeah, let's just do this and see what it returns, and then we can go from there. So let's do this, and then is palindrome 101. Whoops. Okay. And we need to remove this as well. Okay, so it does that. So if I do string, actually, let me look this up quick. So, F# convert character sequence to string. Okay, that's simple enough. So I can do string dot concat. Nice. That's really easy then. So we'll do string dot concat. And I think no. The title is truthful. I'm very new to F#. Okay, so that returns favorable values, and so does that. Oh, be quiet, Google. I have a Google Home Mini in here. Okay, so let's let backward equal that. And if, or actually we just have to return forward equals backward. Okay, so yeah, hello Jav, welcome to the stream, glad to see you here. But yes, the pipe followed by the angle bracket is basically forward It's basically stacking parameters onto functions, but in the reverse order from left to right. So if I were to do, so there's actually two ways that I can write this line here. So I can have it the way I have it written, or I can do sequence.reverse forward, and then put that in parentheses, and then pass that to string.concat. Does that make sense? So basically it's to put the arguments before the function name, if that makes any sense. So that way we can avoid encapsulating this expression here. Yeah, it's really neat. Alright, so we have something to check whether our number is a palindrome. Now, yeah, exactly, it makes it easier to read too. And the cool thing about F# is that you can even compose functions together with a special operator. So let's say we wanted to convert an integer to a floating point number and then take the square root of that. We could do square root n, and then we could simply do float and then compose that on square root, and then we could use it. So then we could say square root n of 9 and execute that, and it gives us 3. So it's really neat, and we could even go so far as to do round, compose it onto round, and then let's see here. Yes, I believe I can do that. I don't know why it's giving me an error. Interesting. Well, we'll leave it at that. You get the idea. Or actually, it seems like it's fine with it now. So let's do square root of 10. And that gives us 3 as well, because it's rounding down. Versus if we just left without the round, it would be 3 point whatever. Yeah, it's really neat. Okay. So yeah, let's go ahead and do our code for the palindrome checking now. So let's let 3 digits equal, and then we'll do from, let's see, okay, so it's 100 to 999. And since that's a lazy sequence, I should be able to just reuse that. So then if I do sequence.zip and then pass 3 digits twice, and I need to check the other argument that this takes. Okay, so then what I could do is a map. And then do a lambda function. And I would take in A and B and multiply them together, and then check the palindrome of that. So actually, what I'll do is this instead, filter. Or no, I think a map would be better at this point. Okay, so I'm gonna select all the tuples that I make out of those two. Basically, I'm listing all of the combinations of 2 3-digit numbers, and then I'm gonna select through all of them and multiply them together. And then I'm going to pass that to is palindrome. Okay. Yes, I need to make these long integers, because otherwise it's going to complain about types. Yep, that's working now. Okay. So, what I want to do is return the product, and then the product whether it's a palindrome. And then what I'm going to do is filter this sequence. I suppose I don't even have to make that a tuple. Okay. Then I can just pass is palindrome to that, and let's see what it gives us. Okay, interesting. So these are all palindromes, as you can notice, and we want the greatest of all these, which obviously would be this one. So I think we have our answer already. That was pretty easy. So I'm just gonna go to Project Euler, since that got closed after I rebooted. And we're gonna check our answer. Largest palindrome product. And we're gonna check that. And that's incorrect. So let's see what happened here. Alright, sounds good, Ouija. Have fun drawing. Alright. So, I'm wondering why this would be incorrect. Made from the product of two 3-digit numbers. Oh! Wait, yes. So I have all the 3-digit numbers here. And it wants the largest of all of them. So to me, this seems like it should be the right answer, but let's double check this. So we'll pass a tuple with a tuple inside of it. And we'll filter by this. Okay. So we have... Oh, interesting. So this didn't do what I wanted it to do. So what I want is... This is where I went wrong. This is only the palindromes that are squares. So what I need to do is find a better way of looping through all these together. And I think how I can do that is, let's see. So basically I need to do a nested for loop, but I'm not sure how I would do that functionally speaking. So I guess what I could do is output 3 digits times. Okay, I have an idea. All right. So basically what I want to do is map 3 digits to a sequence of sequences, basically. So I'll take a map and basically, let's see, return a sequence that is basically itself mapped so that they're all products. Okay, I get it now. Alright, I have a plan. So let's go ahead and split this up into a few separate lines too, so that it's not super confusing. Alright, so what I'm gonna do is take this n, and then what I'm going to do is effectively take 3 digits again, and then pass that to a map inside. Okay, and that map is going to take this function in. So it's going to take the multiplication function, yeah, so the .dib file is actually an interactive .NET notebook file, and what it basically, it's kind of similar to Jupyter Notebooks for Python, except it's for .NET. And basically what this allows you to do is execute F# interactively, but also in kind of like an organized session. Yeah, it's really neat. I figured it was perfect for these kinds of challenge streams, because then I don't have to worry about syntax and all that. For basically making it into a bunch of different like executable programs. It avoids a lot of the boilerplate. I can't speak. Alright. So multiply by, and then we'll take in our number n. And that should do the trick. And then after that we'll do a sequence.collect, I believe it is. It says it's missing its function body. Let's just try executing it. Okay. So it doesn't like it. Okay, so that's the right type. What about this? Let's see the error it's grabbing here. Let's see here. So this itself is correct, I believe. Let's just put this in parentheses just in case. So this is expecting oh, okay. So I believe I actually need to make this a collect, because it's expecting a function. Oh, thanks, Linturny, for dropping by. I appreciate that. And yeah, you always gotta think outside of the box when you're stuck, right? But yeah, thanks. I will have fun. Have a nice day. Alright. So then, all I have to do is filter this. And I should be able to just take in key and do it that way. Okay, that's better. So then, what I'll do is take the maximum of this. So I'll pass it to int64, or I need to map it still. So this is to convert it back to integers. And then I can do sequence.max. Okay. Oh yeah, thanks, Linterney. Yeah, I've worked pretty hard on getting it to look a lot better than the Twitch stream because I just want it to be like more engaging and just a little nicer to look at. Thanks, Jav. But yeah, I think we have our answer here. Let's try this again. And that did the trick. Thanks, Linterney. I really appreciate that. Alright, so that's challenge number 4 done. So I'm gonna go ahead and commit that. Alrighty. So let's go ahead and do the next challenge now. So if we go over here, how does this submission work? Okay, so basically I made a GitHub repository just as an extra thing, but all you have to do to participate in Project Euler is go to projecteuler.net, I think? Yes, projecteuler.net, and sign up for an account there. And then you can go to the Archives tab here. Let me show it on stream for a second. So this is what Project Euler looks like, the website. As you can see, I have myself logged in here. And what I can do is go to this Archives tab, and it shows me what problems I've completed and what problems I have yet to do. So the next one is 5. So I click on that link, and then it gives me the problem, and then it has a field to submit the answer. And that's pretty much it, all there is to it. But yeah, let's go ahead and type down this challenge. And, whoops, that needs to be marked down. And then we'll do this. Copy and paste the problem. Okay, then make this F#, and we are good to go. So let's go ahead and read this out loud. So 2,520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? So there's 2 ways that I can see this going. So actually, let's go ahead and do for 1 to 10. Do, and then I believe what I can do is yield 200 or 2,520 modulo yes, there, and then execute that. Oh yeah, I have to put this in a wrap this in a sequence. There we go. So yeah, I think that's how it's meaning that we do it. So then, I suppose I already have this code written, so let's let, and then after this, let check number n equal this. And we'll indent this, and then make this our parameter to sequence that for all. And then, simply enough, we just do equals 0. Okay, so now let's do check number 2520, and that returns true. Okay. So now let's change this to 1 through 20, and then we'll simply do this. Let's sequence that init infinite int 64, and we'll pass that to sequence.exists check number. Or actually, even better, we can do find. And I think that does the trick. Okay. Oh, okay. So again, I have to do the literal longs. Oh, okay. It keeps assuming it's an integer because I have 32-bit integer constants. And then we'll compose this with plus 1. And I believe that works like this. Let's cancel that, because that seems like it's not going to terminate. And let me just check on the stream here. Oh wow, we have 4 viewers. That's really awesome, guys. I'm glad to have all of you here. Okay. So back to our code here. I'm gonna look up this sequence.find because I don't think I'm using it correctly. Okay. So we want to do find the first element for which the predicate returns true. Okay. So I guess it's just slow. And I suppose what we can do instead is this. We'll do 1, then int 64.max value. And we'll let that run. Seems like a good time to grab a drink of water. Oh wow, okay. It took it that long to return a compiler error. That's interesting. Oh, okay. There we go. And make this 1L. And let's see how this runs now. Oh, you know what I could do to make this faster? I could do this. Okay, so instead of checking all of them to see if they're equal to 0, I can check the opposite. I can check to see if any of them are not equal to 0. And the first, what this function does is it stops with the first one that isn't equal to 0. So then it'll avoid a lot of redundant checking. And then what we can do after that is pass it to not, the not function. And yeah, let's give that a try. All right. That should be exists. All right. So this should be faster, I believe, but still probably slow. Alrighty, so while we're waiting for that, do I have anything entertaining? I don't think so. We'll just wait it out. I suppose the music is enough for entertainment. By the way, what do you guys think of the music? Let's see. There we go. Now the chat seems to be working. There we go. Good, not distracting. Alright, that's great. So let's go. Oh, there we go. Nice. So that took it a minute, but we have what appears to be our answer. So let's go ahead and check it. Nice! So that was the first time I've gotten one of the problems correct on the first try. So that's neat. Alright. Moving swiftly along. Wait, hold on. Yep, that's the right one. Okay. So let's see here. This one has images. So what I'm gonna do is switch over to our browser view here. So this is our browser, and let's read the problem together. So the sum of the squares of the first 10 natural numbers is 385. The square of the sum of the first 10 natural numbers is 3,200, or oh god, I can't read numbers. 3,025. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 2,640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. Okay, that's easy enough. So let's go ahead and commit completed challenge number 5. And we'll sync those changes. All right, so let's go ahead and add our next file. So challenge number 6. Then we'll just say sum of squares minus square of sums, right? Yes, okay. Sum of squares minus square of sums for 1 to 100. Okay, so let's go ahead and start writing some code. Alright, so first thing we'll do, I believe, or actually let's just do let function square n equal n times n. Let sum of n, or actually a and b, and we'll just make this a proxy for a plus b. Okay, so then what we can do is this. So we'll let 1 to 100 equal just that. And then we will take the sum of the squares. So 1 to 100. Pass that to sequence.map. And we'll do square. Then do sequence.sum. Hi, Space Lord. Welcome to the stream. Glad to see you here. How's it going? Sum of squares. You're good. That's great to hear. I'm doing all right. Obviously doing this live stream right now. But yeah, it's been good so far with school, and what else have I been doing? Yeah, just chilling, doing writing some code for both Super Patrick and just for fun. So yeah, I've been great. And then we have square square of sums, and we can do this as 1 to 100. Take that sequence.sum and then pass that to square. Then we simply take the difference of those minus square of sums You were just checking in, but you gotta work on your research thing later. Alright, sounds good, Adam. Have a nice day. Bye-bye. Alrighty. Whoops, I think that is supposed to be the other way around. There we go. And I believe that is correct. So let's go ahead and submit it. All right. All right, nice. We're just blazing on through these, aren't we? Okay. So this next one, I think, is going to be a little more difficult. Let's do... I'm not gonna wait for it to push just yet. I'll do it in larger batches since we seem to be flying right through these. Okay, so I'm just looking for my prime number code. There we go. Okay. Whoops. My dog is barking. I don't know why she's barking. Okay, so let's let is prime equal that. Oh yeah, I forgot. I need to put the challenge over here so that you guys know what it is. Okay. So challenge number 7. And we'll paste this in. By listing the first 6 prime numbers, blah blah blah, we can see that the 6th prime is 13. What is the one... Oh, okay, hold on. 10,001st prime number. Okay, that sounds easy enough. So, let's give it a shot. I believe I can just take this code here, and then we can skip the first 10,000. Excuse me. So let's go ahead and do that. So sequence step skip 10,000. And that should be primes. And then we do sequence dot head. Okay. Yes. I forgot to include that function definition as well. Okay. So we'll let that execute. That was super easy. All right. Let's go ahead and submit our answer. And that's correct. Awesome. Okay. Well, let's see how difficult or involved this next one might be. So we'll do 8. Okay, so this one is actually looking pretty... Oh, I never switched it back to the camera. Apologies for that. I just realized I never did that. So, I think the problem is looking a little more involved than what I have time to tackle for the rest of the stream. So I think I'm gonna call it right here. So thank you everyone so much for watching. I appreciate all of you being here and being along for the ride. And yeah, I'll see you guys next time. Bye bye!